All right, welcome back everybody to another video. In this video, we're going to talk about how we can take the energy analysis that we've done so far on this pink spreadsheet and turn it into a cost savings per year. So we're going to introduce another new spreadsheet. This one is called the cottage gas usage analysis. This is version 1 of that spreadsheet where we're just looking at Ripma Cottage. Eventually we'll add the other 3 locations to this as well. But basically what we've gone through is, what we've taken is the gas bills from Ripma Cottage. So you can see this is our historic gas usage and bills over the last about 3 years. So 2023, 24, and I guess 2022. And what we've done is plotted this up. So here you can see that in a chart. We can see the winter months that we have been simulating. So around here in January, you notice this guy looks consistently a little bit low. That is the billing that happens actually over December. So it's a little low because of Christmas break. But those are the winter months. That's what we're simulating. And we're going to make an assumption that if we are seeing a 20% savings in the winter, that's going to translate to about a 20% savings overall in our gas bill. That's a reasonable assumption. Most of the gas usage is happening in the winter, so that's going to be an assumption that we're going to make. We have to take this, so if we look at the summer natural gas usage, we still see some usage in the summer. That's from heating water. So to have hot water, that runs on natural gas as well. So we can get an estimate of how much is actually used to heat the home by subtracting that out. So that's what you can see in this second chart. Now gas prices and rates are actually quite complicated. So I'm going to pull up Semco, which is our gas company, and they have a bunch of different rates. There are different service tiers for residential, general service, which is more like industrial type customers. We are this top row under residential, and there are a bunch of different charges that you see. We also can see, right, only one of them, this guy in yellow, is the cost of our natural gas. Everything else is all sorts of other stuff that we'll talk about in a second. This is our natural gas cost. If we scroll down, we can see that that natural gas cost is not constant with time. So just like the price of gas at the gas station changes with time, the price of our natural gas is also changing with time. So when we're trying to predict out the future, we're going to have to figure out how we actually can predict what these prices are going to be, say 2 years, 3 years, 5 years from now. Okay. So we're going to go back to this spreadsheet. This is our Semco rate table. So this price here is our cost of gas. This is what it is now. The balance and demand charges, energy waste reduction, and distribution are costs associated with the delivery of natural gas. So those are all flexible costs, which mean the more we use, the more we pay. So these are in dollars per therm per month. So if we use 100 therms, we would take all of these different charges, multiply them by 100, and add them all up. The cost of gas is the kind of raw cost of natural gas. The energy waste reduction helps fund different incentive programs that we learn about from the utility to reduce the use of natural gas. The balance and demand and distribution are funding some of the infrastructure to actually bring the natural gas to customers. Up here at the top, there are fixed charges. So we have $12.25. That's $12.25 for everybody per month, regardless of how much you're using. That's basically so that they're updating the dashboard, and they have employees that need to get paid kind of regardless of whether you're using a lot of gas or not. So that's kind of helps the gas companies fixed charges. And then the main replacement program and infrastructure improvement, those are both fixed charges as well to replace some of the infrastructure that the company has. So you can see in all of these, the actual cost of our natural gas is typically less than half of the the cost of that we're paying on our bill. This chart here on the left is the natural gas spot price over the last about 25, 26 years, which just shows how variable natural gas costs can be. So the y-axis here is dollars per million BTU, which would be like divide by 10 to get to dollars per therm. So we're right here at about 30 cents per therm, which our gas company is going to be charging us a little more than what the spot price is here. But you can see back in the early 2000s, this was quite high, more than double what it is now. There was, this kind of strange spike here in around 2020, 2022, which was kind of a combination of COVID and also some supply changes to Russian natural gas because of the war in Ukraine. So geopolitical events, disasters, all sorts of things can contribute to what the price is. So what we're going to do is to look at this historic data and say this gives us at least some idea of the future. We're not going to be able to predict future geopolitical events, but we are going to try to sort of put bands on what is a typical high cost, what's a typical average cost, and what's a typical low cost. So that's how we're going to play the game. So if we look at this, we're going to try to predict our annual gas bill, by looking at these rates. So there are fixed costs that we have to pay out every month for 12 months. And then there are variable costs that we pay depending on how much we use. So you can see our overall usage is here. That's for both space heating and water heating. And we're going to have a low cost, an average cost, and a high cost. So this is the cost of gas like on this chart. So today, our cost is actually kind of between the low and average. But again, we don't know if today is going to be the same as tomorrow, is going to be the same as next week. So we're just trying to give a band on what those costs can be. How we're going to use this tool is take the percent heating reduction that we calculate in our pink spreadsheet, and we're going to enter that here. So let's say we simulated a weather sealing project on Ritma Cottage. We saw that was going to save about 7% on our energy use in the winter. We're estimating that that's approximately 7% overall. So we type in 7 there on the percent, and we can see an estimated cost savings of between $39.50 and $74. So somewhere maybe around 50 again, but we're looking at like $39.50 to $74. So one of the things that's kind of a really key point to this is all of these calculations, right? $39.50, $50.69, $74.32. These are exact calculations. Even this 7%, 7.0%, that's an exact calculation, but these are not exact answers. So we are, and what I mean by that, these are calculations that we're running through a model that is trying to simulate what's happening at Ritma Cottage, but it's not going to capture everything that could happen. We're not going to perfectly estimate the cost of gas a year from now. We're not going to perfectly estimate how people are actually going to use the space, whether they're going to turn the thermostat up or turn the thermostat down, or have a lot of people living in a place or fewer people living in a place, right? So those are usage habits that we don't know exactly about. But what these numbers do give us is sort of a range of the savings that we can expect. So we're doing our exact calculations. The final answers that we're getting are not going to be exact answers, but they are going to give us information about the future based on our modeling. All right, so these are numbers that we want to save now. So what we're going to do is take these numbers and paste them into our recording spreadsheet. So I'm going to open up our data recording spreadsheet, and I'm going to add right click and click insert. to add a couple extra columns. So this is predicted energy savings. Low, medium, and high. I'm going to take this to make it look a little nicer. I'm going to go and merge those cells. Maybe double click here to make it small again. And then this is going to be where we can record those low, medium, and high savings. So I looked at this first case where I saw the percent reduction from baseline was 7%. I'm going to go back to my previous spreadsheet. So 7% reduction from baseline. I'm going to copy these. So I can go to copy. Then I'm going back to my data recording spreadsheet, and I'm going to paste these in. And I want to paste them as values. So I'm pasting those values. You see it turned them into percents, which I don't want. So I'm actually going to select all this at the top and say, no, I want those to be dollars. So I'll change the way that Excel is formatting those. Now this gives me in one place the change or intervention that we did, about the usage that we expect from that, how much we expected that to decrease the energy usage, and then sort of like error bars, if you want to think of it that way, on where we think the savings is going to come in. Somewhere between $40 and $75 per year. So maybe we want to add that here. So this is predicted energy savings in dollars per year. All right, so now this gives us one place where we can track both the energy savings and cost savings for our projects. So that will give us another thing that we can do to try to look at the performance of all of these different simulations that we're going to do and try to figure out which one is providing the most value to both the residents of the cottage, but also to Hope College's bottom line. All right, thank you.